Hey everybody, welcome to wasmCloud Wednesday for Wednesday, December 11th. I think we've got a pretty sweet agenda set up for today. We are going to start off with a demo from Lucas, who's going to talk through some of the work he's been doing lately on wasmCloud benchmarks. I won't do any spoilers there. I'll let him take you through the whole demo. And then we get some pretty fun discussion items around one of our recent blogs, kind of a throwback to community meeting we had earlier in the quarter around Rust Leptos library, which is for full stack web development in Rust, and how that works with WASI 0.2. And then we only have a couple of weeks left in the year, so probably important to take a look at the roadmap and see what we have left, and then probably do uh, we can maybe call it a cry for help on some of the issues that are left if people are looking for something, an open source contribution to end off their year. So, with all that being said, Lucas, I think you're up first on wasmCloud benchmarks. Would you mind just like talking through some of the stuff you've been working on and why and what you've been able to get up in the in all the things you've been working on?
Yeah, sure thing. So I'll be looking at a way to consistently keep track of Wasm Cloud performance across different versions. And across minor versions, we are doing some performance fixes. And most of the time, we run tests locally, and they look better. We think, well, there you go. Let's pretty much go with this change. The challenge is that every developer will have a different environment. So if I test on my laptop and something shows as beneficial, it might be because I have 3, 4 CPUs more than my neighbor. Usually it's the other way around. I usually have like the smallest machine. But you get the point that the hardware that you test is important. And we set here to create a system that we can run tests on for wasmCloud that use a consistent infrastructure, and that the test is also consistent in terms of how many requests we're expecting, for how long it's going to run, what are the components that will be deployed for that specific test, the versions for everything, if NAT is going to be clustered or not. So there are many variations that you can create a wasmCloud environment. And in here, we got two of the key architectural shapes that we see in wasmCloud, and we combine them into a GitHub repository that we can quickly get a Kubernetes cluster, deploy that shape, that architectural shape, run many tests, collect all the data, tear it down, and do all of that in a cost-effective way. So it's many smaller challenges, but it comes down to how do we orchestrate performance tests to the points that we might be able to add this to our CI workflow. Does that help? Awesome.
Thank
I'm
you.
gonna get started here then. So what I want to talk about, and hopefully everybody can see my screen. Yell if you can, shake heads, something. All right. So the system here is called testbed, and right now we have that in a private repo, and this is going to be open source pretty soon. Just making sure that we remove all the internal bits from it. And what it is about is sorry, I think somebody has their mic open there. It's a set of scripts and Kubernetes manifests that, when put together, get you a workflow that you can get Kubernetes clusters, execute tests, capture data, and tear it down in a pretty quick way. And the tooling that we're using here is nothing new. We're not inventing any new technology for this. We're relying on the shoulder of giants a bit. So we have EKSCTL for bringing up a Kubernetes cluster, meaning this is an AWS setup. We are using kubectl customize to stitch the Kubernetes manifest together. We're using K6 as the test runner, and K6 provides us a JavaScript environment that we can create tests and collect metrics about those tests. And Grafana on the very end of the whole setup to collect data for the whole setup and present us in a decent way. And in here, we can see that we have, it's pretty much a bunch of scripts and many Kubernetes YAMLs. And to get a cluster, you call the cluster create command, and you give it a name. And once you do this, we are creating the necessary AWS infrastructure in terms of VPCs, IAM, node pools, and all of that. A key setting here for the node pools is we use spot instances for everything, even for the control plane. And all the node pools are set to scale to 0. So this means that we only use a specific node pool if that test requires that node pool. In tests that we are using everything inside a single pod, we don't want to spin up 3, 4 instances for NATs that will be just sitting around there. So the scale to 0 here allows us to define our tests and not worry about nodes coming up or down. We let the system bring up nodes up and down as we need. And once that is all done, the cluster is up. We install the observability stack and also the K6 operator, which is the one that runs all the tests. And this whole thing takes about 15 minutes. That's why it's in a screenshot, and I'm not going to make you all suffer through it. Once that is all done, we can take a look at what we have in terms of observability. And what we get here is Grafana, Loki, Prometheus, OpenTelemetry Collector, kind of your usual suspects when talking about observability. And you get access to this cluster via a Grafana proxy, which will run on your local host, connecting remotely, so you can actually see nice graphs. We also precede Grafana with some dashboards that will help us collect data right away. So we don't need to think too much about, should we add another metric here, or if we need to compose a dashboard for a specific test. By the time you kick off the test, data is being collected, and you can already visualize the information throughout the whole system. And we are interested in information about the test itself. How many requests per second are we sending? What's the latency? But we also want to know about how saturated the hardware is. What is the CPU load on that instance? How much NAT is consuming versus how much wasmCloud is consuming. So all that information is being captured at once in a single dashboard for us here. The other important bit is having these little things so you know when a test started and ended, which is something that by adding here, we keep track of. Was this an HTTP test? Was this a messaging test? So this gives us that information. And what is a test scenario? A test scenario is composed by a given wasmCloud architecture and many tests. And those tests will require some WADAM manifests to be deployed together. So we package that all into individual directories in which each directory for a test comprises of the K6 test script that we're going to use, and also the components and providers that we need to deploy for that test. We get all of this, and we deploy that on top of a wasmCloud cluster. And to run those test scenarios, we, again, call a magic script. And with this script, we pass in which scenario we want to validate, and the script takes over from there. It's going to take care of deploying wasmCloud cluster, wait for the wasmCloud cluster to be available, so all WADAM, NATs, wasmCloud hosts are reporting correctly. After that, it deploys all the components for WADAM, and again, waits for those to reconcile, get deployed everywhere, and that's when we actually kick off the tests. By the time that we have everything deployed and the system is stable and ready to receive tests. We run one test at a time. We wait, again, wait for the system to get a breather, and then we go to the next one. And this means that when you run a scenario, you bringing up the infrastructure, running many tests, and tearing it down, all with a single script. And in terms of architectures, so what are we even testing here? We're testing a concept of a blue and green cluster. It's a cluster where we have 3 nodes dedicated for NATs in cluster mode. And then we have a host group called the green host group and a blue host group. And these are essentially the exact same wasmCloud host deployed side by side there on individual machines, but each one has a different label. And by using this label, as we write our tests, we can test not only the wasmCloud communication with its internal components, but also different properties of how wasmCloud behaves when you have to cross the host boundary into another node. And a scenario here that is pretty common is you need to run an HTTP provider and you need to run a HTTP component. This setup here allows us to run the provider and component on the same hardware, or to split them and run the provider just in the blue cluster and the component on the green, forcing a network hop on NATs on every request. So in this way, we can get different performance characteristics. And the other shape, which is the one that is the most used, is everything on the same node. So we have Wasm, NATs, wasmCloud, everything running on the same machine. And that one is your developer environment, or you're just trying out wasmCloud and you have everything deployed on a single node. So this one is pretty good for tracking individual bits of performance. We change the setting in ccTL. We run this test again to kind of get a confirmation. And the tests themselves, again, we're not inventing anything here. You write your WADAMs, your application manifests. In this one, we're testing a new feature, which is a wasmCloud built-in provider. Hopefully, I'm not stealing any thunder here. But built-in providers are coming. And with this, we can write a test that sends a NATS request and interacts with that provider. So this is to say that any sort of component that you deploy, if it can receive HTTP or NATS, you can test with this setup and at any scale. Once we get to the data that we collect, again, we have the start and end markers, and every single metric is going to be isolated per test. So you can actually click on them and make everything else disappear. And we also collect data for WASI messaging and for vanilla HTTP, which is one of the ones that we run the most. And I talked a lot, so I think we better see this thing. And what I'm going to bring here is get out of this, make it bigger. So the first thing I'm going to do is I'm going to get access to this cluster that I already have set up. And that's going to be this one here. I was running some tests up until a few minutes ago, so this is going to just dial down. But to show around, in this view, let's get this test that just finished. So you see that the cursor is kind of linked to all charts, so we can actually see exactly the properties of each section. But if we go to the very first one here, and we see this is a test starting, and it's going to be the all-in-one message built-in test. So we know that between here and this marker, which is the end of it, everything that is happening has to do with built-in messaging tests. And in here, we can see that K6 is ramping up iterations, which means it's trying to push more and more load onto the system. It's not going for a constant rate. It's literally trying to stress it to the point it breaks. And with the built-in provider here, we were able to scale it up here and push it as far as around 10,000 requests, which I think is the setting that we have for the cap that we have for this test. But then once we look at the other side here, we can see that once we are around 8,000 requests per second, latency starts to take a serious hit. So even though we can serve many requests, we can serve 10,000 requests, by the time you get to 8,000, you start to see some latency penalty here. And just kind of remembering that this is specific to this environment, it's specific to this test, and can show the settings later, but this doesn't, it's not saying this is the limit for the built-in provider. It's saying this is what this hardware is capable of doing. And down here, around the same time that we are running this test, we are also collecting the resource utilization on all resources being tested. And in this case here, again, we can see that, yes, we are going to 10,000 requests. And once we get around, I can see up there, but it seems like around 5 or 6, CPU starts to shoot up, which once again gives us a scent of where to go look for possible improvements. But then the next test here is our friend messaging provider, which is not the built-in one, which is the one that runs as a side process to wasmCloud. And it has literally the same settings as the built-in provider. But then we see that the throughput here is significantly less. And also the latency, it starts already way higher than the built-in provider. So, and this is kind of the style of test, the kind of tests that are interesting to us, is to identifying the different properties and in which situation to use which approach. Yes, a built-in message provider is yielding more RPS here, but what if I trying to run this component in a remote location? In that case, I want to run my provider in the cloud, and then I can run the component on a Raspberry Pi somewhere else. So in that scenario, I cannot use a built-in messaging provider. Should I go to am I okay with this amount of RPS? So this is all to give us more information about things. And having here each test separated with its own metric means that we can quickly isolate them. So I know for sure that I'm only looking at the built-in HTTP test in this case, and this one is only the provider. And if you want to compare, you can kind of select both. So this gives us just enough information to start investigations in terms of wasmCloud performance. How does this data get here? Let's go back here to the tailing part. We run scenarios, like we were saying there, by running the script. So you call the scenario and it kicks off everything. And I'm going to narrate as it does. So here we see that it's deploying wasmCloud, and now it's waiting for wasmCloud to be up. It just confirmed that Wasm has been set up remotely, and now it's waiting to deploy the manifests. Manifest deployed, waiting for Wasm to get the report from the host that all components and providers have been deployed. Once that happens, we start the test. And for this test here, we are using K6 operator. It is a distributed test. And the way that it operates, it starts as many pods as we request, but puts them in a wait state. And then there's a trigger that tells all pods to start the performance test at once. And this way, you don't get a scenario where you start all your pods and each one is starting at a different time and thus giving not the same amount of requests per second you were expecting. So as this test is running here, if we go back to Grafana, we see things that are already starting to show up. Once again, we have the marker saying that the test started. And then this is going to go and give us something that is very similar than what we saw in the test that was running before. So I'll stop here and to to say that all of this is going to be open source. These tests, they can be configured by users. So in this case here, I'm just going to show the case that for the cluster environment, you get to pick which wasmCloud image you're going to be using, what them image, NATs, and so on. And you also get to pick how many of those you're going to be running per group and any sort of node placement constraints that you want to add. One thing that we're kind of doing here as well is for the blue-green cluster, we run the green cluster with a higher log level than the blue one. And this way we can send some requests there mostly to check if wasmCloud is emitting errors under different circumstances. Okay, so I'll stop here, and I'm not sure if there's any questions or any follow-ups, but this is going to be open source, and we will also look to start publishing a bit more information about historical performance data for wasmCloud and see how we can make it as fast as possible here. So, not sure, Brooks, if we're doing any questions or if we're going straight back to you.
No, please questions. Yeah, questions.
What do you see that you'll be testing the most going forward? Or like where do you see this going?
Yes. And I just saw here a comment about the PowerPC transport. And this is part of it. And the one that we see the most is the combo HTTP provider, HTTP component. So this one is one that we have a little recipe for tests that we really just want to grind it, like run it over and over. The other ones that are quite interesting is replicating application behavior. And that means think about you have a component that is the API gateway and is receiving the request, making a decision, and sending requests to 2 or more other components downstream, thinking that one of them might be like a lifecycle handler for marketing that you need to communicate with, another payment service that you need to ping, a logging system that you need to communicate within the same request context. So introducing varying numbers of downstream requests and latencies. So we mirror what we see in applications. Messaging is one that I feel we're going to start seeing more and more as well. Wasm messaging, that is. And this is because if you squint your eyes at as providers, the WebRPC providers, when you do the WebRPC providers over NATs, you could be doing that over Wasm messaging if you were not using WIT for your payload definition, because the WebRPC over NATs is pretty much using the same mechanism, but the messages are framed by a WIT. And this is to say that by testing Wasm messaging, we test a good part of the path that the WebRPC is going to be using. So making Wasm messaging as fast as possible also helps us making the WebRPC as fast as possible.
Yeah, Lucas, is there anything else that you wanted to say on Masood's question around WRPC transports? And yeah, like we definitely have at least seen a baseline here around the built-ins and providers.
Yes, so for WRPC, the interesting things here is mapping individual performance for each transport. So Unix domain socket, probably not going to be part of the test, but anything that is networked, so TCP, QUIC, NATs, and understanding the performance characteristics of those, but also at which scenario to use them. It's probably the case here that QUIC and TCP for WRPC will be faster than NATs. But by doing that, you don't get NAT punch through. You don't get routing. You don't get the ability to inspect the messages there without doing ngrep and having like privileged containers. So I think mapping them is important. And this will also help us look forward in creating situations where maybe the WRPC links will go through a different protocol. Liam.
I love the examples, the WRPC Wasm time that were put out here, Colin. But in response to, and Colin looks like he dropped. Um, but but generally, what we're trying to do with the testing framework here is to just give us more regular baselines of performance as a whole. And benchmarks are really hard. But for various use cases, we really want to build in a couple of common patterns that we see around platform engineering and people at scale and get those built into, maybe not every commit, but certainly every release so that we can sort of say like, hey, are we still within some threshold of performance? And really, raise the bar so that all of our users and fellow developers of wasmCloud, you guys, the folks here on this call, so that we all have some numbers that we can depend on as we build products and services and ecosystems around the tech. So that's what our intention is in creating this and putting it into the first the open source and perhaps later into some kind of a automated CI/CD system so that this happens with commits or versions, or we can kick it off at regular intervals or something like that. In the dream, if you've ever seen the Are We Fast Yet website that Firefox famously ran around, different performance testing and different scenarios, at some future time we might have like, CPU bound workloads, different messaging bound workloads, HTTP, centered workloads, and other kinds of common use cases so that we can sort of trend them over time and understand when we make changes to WRPC or when we make changes in WASM time, how does that impact the ecosystem as a whole? Because there are a ton of moving pieces here, and a frequent complaint and frustration that we've had is consistency. So this is just a desire for us to help us as an ecosystem raise the bar. We are incubating now, after all.
Yeah, maybe this was already covered, but repetition is fine. Lucas, do you see this being something that, we open source this and then this becomes something that can be kind of manual kicked off as a part of a PR workflow, like, hey, in this PR we're updating WASM time, let's see how the performance is as we go one version to the next, or we're changing the WRPC version, or hey, this code that you updated totally changes the way that we're doing HTTP routing. Let's make sure that didn't mess anything up. Do you see the first iteration of this being kind of manual on demand, or do you see us just like full sending this to like run this on every PR?
So the full sending is interesting because I feel like we're not far from it. The key thing here is who starts the test, and if whoever starts the test is going to be waiting for the test to finish. And I say this because it's the entirety of a test run. Let's say we're validating performance on a per release basis. We're talking about 25, 30 minutes of CI time if CI is waiting for the test to finish. And with GitHub Actions, I don't think you can use that much in the free tier, like in terms of CI minutes in one workload. But the whole point is, even if it is possible, it's leaving a lot of resources not being used. And it's so the goal here is maybe this is more of a GitHub hosted runner that we need to put together. But I totally see this being called throughout the CI pipeline on pushes to main, validating performance there. The very first one that is easy to put together and validate all of this is a GitHub workflow that can be triggered by maintainers. So this becomes a way for people to go in there, kick it off when needed. After that, we go into a nightly mode. So pretty much using GitHub Actions, scheduling a nightly run. And after that, we go on every pull request. But this is still something that, yes, I do see as being added to the system. Also see this being open sourced. The thing to keep in mind is it is our opinion and our settings. And the expectation is as we talk about different installation sizes, different configurations, we can quickly configure this test bed to fit that model and quickly validate. So it's not intended to be, this is how you deploy wasmCloud. This is how we are keeping the infrastructure consistent throughout our validation story.
Yeah, awesome. Folks, I think the discussion items at the end of the call are going to be somewhat quick, so we have a few more minutes for questions if anybody had more for Lucas and team. All righty. I think that was long enough. Thank you so much, Lucas, not just for demo, but presentation background. It was awesome. I can't wait to get this integrated into the repo. All right, folks. Well, then why don't we go ahead and move on to the other two agenda items that we had for today. So first and foremost, we wanted to call attention to a really awesome blog that just went out on the wasmCloud site yesterday on Tuesday, which was, I'm not just saying that because I co-wrote this blog or whatever. I'm saying it because Enzo, who is on the wasmCloud community call on October 30th, the spookiest call of the year, did an awesome job with integrating with Leptos, which is a very popular Rust full stack web development framework, and actually implementing the bindings and the ability to use this framework with wasmP2. So what this means is you can actually write web applications, full stack web applications in Rust, and then compile it to the WebAssembly 0.2 target, which is essentially the target moving across to be stable on in one of the latest versions of Rust was a big mover for this. And then you can run that in Wasm time. You can run that in wasmCloud. Because wasmCloud is just on the WASI 0.2 standard, it doesn't really matter. You can run it in any Wasm runtime. I believe that has HTTP and file system, as something that you can interact with, which is awesome. As far as my cheeky comment about co-writing this blog, in this post, I wrote an introduction for Enzo, and then the very last paragraph, he added some incredible content. I would highly recommend taking a look at this blog. He wrote about his reasoning why he is interested in WebAssembly. He's not on the call, right? I'm not just speaking for him. Okay, no, he's over in Europe, so I think this is kind of late for him. But he's got a pretty sweet diagram here to talk about how the whole Leptos integration works. This is really just one of the latest examples of how the P2 target and then integrating this with under popular language libraries is a really sweet uplift for just the entire WebAssembly ecosystem. So I highly recommend checking this one out. It's on the blog page. Do folks have any questions on this blog or what this project does? I can try to field them, but maybe only high level things. Sweet. Well, yeah, definitely check out the blog. Let us know what you think, and give Enzo a taco if you see him in the wasmCloud Slack, because it was really awesome to work with him on getting this blog out. Other than that, just to round out the community meeting today, I wanted to do a check-in on the quarter four. Oh, sorry, I missed chat. Yep. Yeah. Thank you. In the chat, we got that it's really awesome to see it. So good job, and so good job, team. Just to round out the rest of the year here, wanted to check in on the quarter four roadmap. Sounds like as we go forward into our community planning session, which will be at the beginning of next year, we'll definitely want to talk about our benchmarking suite and actions that should probably go on there as work that we're planning to do, which is great. And taking a look, we've had some really awesome movement on this roadmap over the last, I think 2 weeks was the last time that we checked in here. Now we've certainly made a lot of progress across the quick start, and I think once we release the next version of Wash, which includes a couple of fixes, or sorry, a couple of new features for Wash Dev, we'll be able to say that our wasmCloud quick start has grown three times its size. I can't remember the Grinch quote. So that one will be able to cross off pretty soon. We've done a couple check-ins on we have open source. Yeah, 3 sides of that day. Thank you. Have a couple of open source contributors who have swung in on wash control commands, on using human time instead of milliseconds, on using clap autocomplete. All of those things are actually, I believe all of them are open, at least draft PRs right now. So just follow up with some of those contributors there, but those should make it across the line just fine. Our very own Masood has put up a PR for the Nats object store implementation for Wazi Blob Store. So it's not his fault anymore. It's more on the maintainer side for us actually getting some time to sit down and review that one. So awesome work there. Masood, please feel free to jump in if there was anything you wanted to say on that. Obviously, producing a benchmark suite that we can update and publish regularly. We'll mark it as in progress maybe until it's open source and it's something that we can consume, but that one has had great development over the last couple of weeks. Thank you, Lucas, again. Multi-tenancy in wasmCloud has gotten some really great comments. I am not sure if this one's going to be fully wrapped up by the end of the year, and I think that's okay. Every roadmap has things that we plan for and then ends up just not quite making it over the line, and that's totally fine. Other than that, I did mention doing a little cry for help, but what I really mean is a call to action. There are a couple of really good first issues here on the roadmap, especially moving the HTTP server capability provider documentation out of the README and onto the wasmCloud doc site. That's very much like a markdown editing, but would be very helpful for us. So I'm sure one of us will be able to knock out that chore eventually. But if folks are looking to make a quick contribution and kind of get a feel for what the HTTP server does, that's a great one to take a look at. And then last but not least, I think the reflecting unhealthy providers in application status is a great first issue for getting a feel for how Wasm works internally and kind of the deployment topology when a capability provider says, oh, I've failed my health check, something is wrong. We should be able to reflect that in the application status so that if it says that it's failed, you should be able to look at Wasm and see your application is in kind of a failed state, because that's probably something that's external to the app. Think like trying to listen on a port and it not being available. That may be a failed state or failed to connect to your Postgres database. So both of those are great first issues for taking on the roadmap. As usual, if anybody's interested in taking one of these issues, just comment on it and say, hey, I want to take a look into this. Anytime is great. Otherwise, I think we're making really great progress on the roadmap, and the name of the game is just going to be wrapping up some of these last couple issues. Looking forward, I think we can expect, if we take a look at the calendar, we can expect, I think, pretty much everybody to be relaxing on one of the last, or on the last wasmCloud Wednesday of the year, which will be December 25th, and then the first wasmCloud Wednesday of the year, which is January 1st. So Christmas and New Year's, I think we can expect those to be pretty quiet community meetings. So I think we'll plan to do our community road mapping session for January 8th on that Wednesday. Wednesday or the next one, somewhere around there. I understand that planning when a quarter is started is a little lame, but open source work is quick, changes rapidly, and the roadmap is really just I think a great way to collect what we know we want to do of the quarter. Yeah, Masood, go ahead. Probably
Masood,
lost mute button.
are you muted? Yeah.
Muted, sorry. I'm just asking, when are you planning to open up the conversation or the discussion about input to the next quarter planning so we can put our input in?
That's a great question. I think, Masood, you were one of the people who gave the best feedback on our previous our GitHub discussion for quarter four. Do you feel like so I'll just ask you directly, do you feel like the GitHub discussion was a valuable medium to do that in?
Of course, I mean, people who use GitHub are used to that. So I assume that we can continue leveraging that. I
Okay.
have been checking pretty much every week to see that when we start that.
Oh. Dang it, you should have let me know sooner. So it's your fault. No, I think anytime. I will open up the discussion for quarter five, right after quarter five, LOL, for quarter one of 2025, right after the call. And to your point, since you've been looking every couple of weeks, I think maybe we should open up that discussion, maybe right after the planning meeting for quarter two of next year too. I don't see any reason not to have a discussion open where we can start floating ideas for kind of the next phase. Speaking of though, I mean, this is the community call. Everybody gets feedback here. Do folks have any opinions on the discussion place? I personally picked GitHub discussions for the last one because though our Slack is lively and all the maintainers and tons of contributors are in there and talking, I want to make sure that it's accessible for as many people as possible, and not wanting to join a Slack is pretty reasonable, and everybody's got a GitHub, so that feels like a pretty good place, but open to any ideas there. Yeah, GitLab. All right. Well, thank you so much, folks. Really excited getting to the kind of the end of the year here to look back on all of 2024 and see the progress that we've made over wasmCloud. Actually, it's easy to forget that wasmCloud 1.0 launched in April of this year. So about what, no, that's not how math works. 7 months ago? Sure. 8 months ago. So kind of coming up on that year milestone. The community road mapping sessions started late last year as well. So I'm really excited to look forward to 2025. So all of that aside, we are in kind of the open section of the community call. So if folks have any questions from the Wasm Cloud community or general Wasm landscape, now's a great time. Just feel free to raise your hand or talk. And I see Taylor has already got his hand up. So Taylor.
Yes, I'm gonna pull a Liam here based off of that roadmap discussion and gush over the community for a second. Sorry, Liam. So I just want to say I'm not sure how many people noticed that with what Brooks was showing. Like, it's been really impressive to see the community grow, and it's a big thank you to all of you who have been contributing and helping out with that. We're going to be looking at finding ways to recognize a lot of that contribution here soon. But oftentimes I'll see a thing pop up and then I'll go to answer it like when I have time, like 30 minutes later, and somebody already answered it who isn't one of like me or Brooks or Bailey or something like that. So it's really cool to see that going and to see so many issues come in and people feeling empowered to do it. So I just want to say it's really awesome to see all of you there, and thanks for all the help. We really appreciate it as a community to see that growth happen. And so, yeah, just doing a little bit of gushing over that here as we get towards the end of the year. It's been really awesome to see all of you doing that. So we look forward to continuing that collaboration here.
I'm glad that you let Brooks off the hook.
All right, folks. Any other questions or things that you wanted to discuss today?
I just remembered one more. This one isn't a gush. This is a reminder that especially if you're in Europe or you're going to be in Europe around KubeCon, the wasmIO deadline for CFPs is December 22nd. So if you have anything you've done, wasmCloud related or otherwise, we'd love to see those submissions there. This is like where all of our fellow Wasm nerds all get together. So I mean, any type of topic is pretty welcome at this, and it's always been a great conference. So just calling that out for people.
Sorry, Taylor, just a clarification. Is this the one that goes to wasmIO or the wasmCon?
wasmIO. Currently, there is not, and Liam can correct me if I'm wrong, there's not a current scheduled one because generally this conference has been done and Sergey does such a good job. And then here's the thing. The one, Caroline, that was the one from last year, if you want the reference of what was done, the 2024. And then this year's is just the wasmIO, and it's always in Barcelona. Same place, right on Diagonal, that we're at all the time. It's a really nice venue. Fun conference. So yeah, it's not WasmCon, but it's wasmIO, and a lot of us show up there.
All right, folks. Well, I think that's probably it for today. Thank you so much for coming to the community meeting. Really awesome to see some all the old and new faces in here. I think we will go ahead and call it for this one, and then we'll see you next week on December the 18th.